So this is one of the easiest ones to learn, and it's very similar to when you select variables with the subset function. So it's a great one to start with, and it's very useful. So with the subset function, you can choose a subset or smaller number of variables within a larger data frame. So that would be similar to subset, the subset function, and you would put select and equal certain variables within it. Fortunately, the syntax here with select is greatly simplified. You, as I said, just put whatever data frame that you want to manipulate here. You have the pipe function, and then you would have a select function. So inside of the select function, all you have to do is literally list the variables you want to keep. I'm going to go over how to eliminate variables in a second, but this basic structure would select variable 1, variable 2, and variable 3 from a larger set of variables. So this gives an example. This is what is in my code. You could try it right now if you'd like. So when you upload the data that I gave you, it's a bunch of census county level metrics. So this has a ton of information in it. This is what dplyr would be great to use for. Like this particular census data set has 70 variables in it. So if you're using this data set, you would probably want to subset the 70 variables into a group of smaller variables that would be more easily manipulated. So if we have the census data set, which has 70 variables, we would then put the pipe in and say in this particular instance, I would want to select the county variable, the percent less than poverty. So that would be the percent less than the federal poverty line, the unemployment percent, and the percent with greater than a high school degree that has ages 25 and up in that particular case. So that's what it would look like, the dplyr function, if I wanted to subset to these particular variables. And if you run that, you'll see when you take that same column names function, you'll see that my data set was subsetted to county percent, LT poverty, unemployment percent, and the percent with greater than a high school degree. So that's how it would be used in its most simple form. Before I go to eliminating variables, does this all make sense? Great. So similar to the subset function, you can also eliminate specific variables and then keep everything else. So what I'm going to show here is that removal process. In order to remove variables, you put a hyphen before the variable that you want to remove. And there's two different ways to do that. So you can remove a vector of values. See here, I'm putting the negative in front of a vector of a variable. Then that will apply the negative value to variable 1, variable 2, and variable 3. The other way to do it, and these two are completely equivalent, is to take that variable 1, variable 2, and variable 3, and you have the hyphen in front of all three of them. That will also get rid of these variables. The reason that you would probably want to use one of these is if you have a smaller number, or say you want to keep a certain variable, you could take the hyphen out and then have hyphens for the other ones. So you can mix and match these values as well. So this shows how to use that select function in a different way. So the reason I would use the negatives instead of just selecting a certain number of variables, say you have 70 columns like our other data set that had, and you only want to get rid of 2 of them. So you can use this hyphen for that, and it'll keep the other 68. If you go back here, if you listed all 68 variables in the select function, that would take forever, and it's not necessary. So there are also some helper functions that you can use with select. Are there any questions about this so far? Okay. So the select function, there are specific things that you can use inside of it, which are really useful. And I'm going to actually show a coding tutorial of what this looks like. So if you want to get to say choose variables that all started or that contained a certain string in the name of the variable, you could use contains. You also have starts with and ends with. So this would subset variables to everything that started with a certain string or everything that ended with a certain string. And this one is easier to see in action. So pretend that you have variable 1, 2, 3. So this will pull anything with variable 1 and then a 1, a 2, or a 3 connected to this variable 1. So this would be equivalent to selecting variable 1, variable 2, and variable 3. So you have to put the string here and then the numbers that would come directly after it. I'm going to go into my code and show, and that was turned off. So I'm going to go in and go to my code. All right. So this is what is available on our on the shared drive. Remember to use install packages dplyr if you do not already have it installed on your computer. I put this up here. I commented it out because I obviously do already have it installed. But if you don't, you'll want to use uncomment this and then use it. But in my case, I'm just going to take it and run the library function. So, excuse me, it loads the dplyr function. That's what it looks like. So it's basically turning off some certain functions and other packages in that case. So one thing that I just to keep in mind, do not use dplyr with the plyr package because it will, when it does these, say, turning off certain variables, certain functions will no longer work with dplyr. I really recommend not using them both in the same code and finding another way to do it. So that's the plyr package. So if you took the D off of it, that's what you do not want to use with dplyr. So I'm going to set my working directory and the census data. These are going to be shown later to how to merge these in. So a lot of this would be the type of manipulation that I would use in order to create the data sets I have for you. So this data and most of it that I've given you to start has already been cleaned, but I use these functions in order to do that. So this is what was shown in my PowerPoint. So the census has 72 columns in this particular. I had added a couple columns. So we then have this census small. This is where I am selecting county, percent less than the poverty, unemployment percent greater than the high school degree. So if we do that, this creates census small with only these variables. So now you would want to check your work and make sure that the variables you put here are listed down here. If you make a typo, it will error out and say that one of these particular variables was not found. I can just show you that real quick. So that doesn't exist in my data. Now it's telling me that percent greater than high school is not found. So if you do make that typo, it is going to error out and show you what you did wrong. So we know by using this column names that it worked. So I also wanted to show you what this looked like. Say this new census small, I wanted to remove unemployment percent. So if I run that and then run the column, unemployment percent is no longer in our data set. So I also wanted to show you how to use these helper functions, which should make a more sense. So I want to show you when would be a good use case for these. A lot of these variables would be. So say I only wanted to pull these top variables, for instance, you could put pop underscore total, and if it started with that, it would pull all of these values. The example I gave was contains total, so it would also keep all of these variables. And then it's going to keep anything that contains total, and these are the only ones that do contain total. And then the other one that I'm telling it to keep is greater than 65. So if you come down here, this is telling you the number of individuals in each individual county that are over 65 in particular years. So this is a great use case for contains, because printing, or typing out all of these different variables. So there would be, I think that there's 9 in here. I'm not going to count, but so it will pull all of those instead of having you type out all 9 variables. So that is really useful. And I'll show you what that looks like when you run it. Now you see we kept county, state, FIPS. FIPS codes are for merging. I'll show you that later. So each county in the United States has a FIPS code, and that allows you to very easily merge census data. And that's actually what I use to create this gigantic data set. When you pull stuff from the census, it always has this here, and then you can merge easily in case, say, states were spelled differently, because a lot of outside data sources also have FIPS codes. So that's good to keep in mind. So now we're seeing that anything with total and anything with greater than 65, along with these 3 variables, were kept. So that shows you how that would be used. Are there any questions about that particular select? Since it's the first function we're going to go through, hopefully I want to make sure you understand that. So just real quick, I'm going to go back to this one. So this would be similar. What I meant by you don't have to use that $sign syntax here. So the way that dplyr works is it's going to, as I said, dump this into variable 1, variable 2, and variable 3 when into our select statement. So it's automatically, say, doing the same thing that the $sign would do. It's connecting this search data frame with these 3 variables so that you don't need to do that $sign. It knows that it's within this particular data set, which makes it a lot easier to deal with. Are there any questions so far? Okay.